Okay, ladies and gentlemen, now that we have gone over our real numbers and we remember what numbers are, we're going to start looking into this idea of a polynomial. Before we get into a polynomial, poly means many, okay? Nomial of sorts means terms, and we're going to go over all of that, but we're going to look at a monomial, okay? And a monomial is an algebraic expression consisting of one term. So if you kind of look down here on the left-hand side on this little box down here where it says monomial, you have 10. That's kind of like one thing. 3x, it's kind of like one thing. Yeah, there's a 3 in here, there's an x, but they're being multiplied together, so they're kind of together. 1/2 ab squared, same thing. One kind of unit of things, and then negative 1.8 m to the fifth. Those are all examples of one term or a monomial. Now, the degree of a monomial is found by adding the exponents of the variable or variables, okay, depending on how many there are. Keeping in mind, variables are x, y, z, a, b, c. So if you're looking at 10, that doesn't have a variable, it's just a constant number. But if you look at 3x, that has a variable, it's x. So when we're looking at just monomials, first of all, we already went over that in the first table there on the left, those are all monomials, okay? If I'm looking at the degree, I'm looking at the exponent. So you're like x squared, x to the third, x to the fourth. You're looking at the exponent on the variable. Well, if I look at 10, 10 doesn't have a variable. So if it doesn't have a variable, there's really no exponent. I mean, we can make an argument that there is one there, but the degree would be 0. Okay, and if you remember anything about degrees, if something has a degree of 0, it really goes to 1, but I'm not going to get into that much now. Now, 3x. Okay, well, there's only one variable there, and the variable is x. So what is the degree or the exponent on that x? And the answer is 1. Okay, that's 3x to the first power. Anything raised to the first power is just going to be itself, so the degree would be 1. Now, 1/2 ab squared. If I'm looking at the variables, I have two variables. I have an a and I have a b. Okay, well, because now there's two variables, I'm going to go back and I'm going to have to add those exponents or add those degrees. So the degree on the b is 2. It's b squared. And the degree on the a is 1. You can't see it, but it's implied. So the degree on that monomial would be 3 because you're adding together the 2 and the 1. Okay, and then the 1/2 doesn't mean anything. In the previous example, the 3 for the 3x doesn't mean anything. That is something else that we're going to define later. Now, negative 1.8 m to the fifth, there's only one variable there. It's an m, okay, and the degree on that, or the exponent on that, is a 5. So the degree on this guy is just flat out 5. I don't have to add it to anything because there's no other variable. Now, not a monomial, also not a polynomial, is 5 plus, or I'm sorry, that was a misstep. That is a polynomial. Don't pay attention to me. But 5 plus x is not a monomial, and the reason is because it has two terms. Okay, a monomial has one term. This guy has two. He's got a 5 and he's got an x, and they're separated by a plus sign. Okay, not a multiplication sign. So they're kind of separate here. That's two terms. Not a monomial, 2 over n. The reason here that cannot be a monomial is because the variable is in the denominator. When you're working with polynomials or monomials, you are not allowed to have variables in the bottom. They can only be in the top. Okay, so no variables in the denominator. 4 to the power of a, also not a monomial. The reason here is the variable is the exponent. Okay, that's not allowed as well. You can't have a variable as an exponent. It's just not allowed. You can have a number as an exponent. You know, if this was a to the fourth, if we switched it around, that would be okay. But you can't have a variable as an exponent. And then last but not least is x to the negative 1 power. This is not a monomial, and the reasoning here is you have a negative exponent. That's not allowed. If you remember your exponent rules, what this actually does, that negative exponent, actually flips this to 1 over x. These are the same expression. And the second I flip that using that negative exponent, it goes back up to the second one that says 2 over n, where you have a variable in the denominator, and that's not allowed. Okay, so just make sure you know the difference between what a monomial is versus what a monomial is not. Okay, a couple examples. Find the degree of each monomial. Take a look at letter A, 5x squared. Degree is the number on the variable, or the exponent on the variable. The variable we're looking at here, x squared. The degree is 2. Letter B, negative 1/2 xy cubed. This one has 2 variables. He's got the y and he's got the x. The degree on the y is a 3. The degree on the x, can't see it, but it's there, it's a 1. So because this guy has 2 variables, we add those together. The degree would be 4. Letter C, 8x cubed y cubed. Again, this guy has 2 variables. This guy has a degree of 3. This guy has a degree of 3. We add those together. His degree ultimately would be 6. And then last but not least, letter D, we have negative 3. So the exponent on the variable, there is no variable, which means our degree is going to be 0.